Alright, so we are going to review solving equations to prepare for our summative. So when we are using solving one-step equations, our level N, we're going to use inverse operations. So inverse operations to isolate x. Who can give me one of the pairs of inverse operations? So like when you see one, you know you're going to do the other one. Like what would go with addition?
Subtraction.
Subtraction, right? So addition and subtraction are inverse operations. What's the other pair of inverse operations we use, Quentin? Multiplication and division. Okay. So we're going to go through and we're going to review using these and also kind of showing how we traditionally solve them by showing our work. If you do it a little bit differently, as long as you're showing us what you know, that's okay. So here we have x minus 5 equals negative 3. The operation that we see is subtraction, right? So if I see subtraction, I'm going to use what?
Addition.
I'm going to use addition. Now, for some of you, you might not need to add these extra notes at the top. That's fine. For some of you, it's a good review. So I'm going to use addition, and I'm going to add whatever had been subtracted. So here, because it's subtracting 5, I'm going to add 5 to both sides. I also know some students really like the river, right? You draw the line down the middle. Feel free to do that. You do not have to if you do not want to. Once we add and subtract the same thing, it becomes eliminated because it goes to 0. So on the left, we're just left with x is equal to, and then negative 3 plus 5 is going to be 2. Okay? So that's solving a one-step equation. When we see subtraction, we use our addition. Okay? Alright, and then the next one, 8 equals w plus 6. The operation that we see is what?
Addition.
We see addition, so we're going to use subtraction. Exactly. Now, even though the variable's on the other side, it doesn't matter, okay? We still follow all of the same steps that we would regardless. So we're still going to use subtraction on both sides. Again, if you want to make sure you've done the same on both sides, you can add that river in there if you like. On the left side, we have 8 minus 6, which is 2, equals, and then on the right side, we're left with just w. Now, standard form, we usually have the variable on the left for our answer, so you can rewrite this as w equals 2. You don't necessarily have to. It's just when you see in like textbooks or online, things like that, it'll have the variable on the left, usually with your final answer. Alright, number 3, 4x equals negative 12. The operation we see is what? Multiplication, so we're going to use division.
You divide both.
So I'm just going to abbreviate those, multiply and divide. So to show the division, we use the fraction. So we show that we're dividing on both sides using that fraction bar. Because if I divide 4 divided by 4, it becomes
0.
1. So 4 divided by 4 becomes 1, and that's what we want to know. 1x, what is that? So you can write it as 1x, or you can just write x, and then negative 12 divided by 4 is negative 3. So your final answer can be 1x equals negative 3, or just x equals negative 3. Both are accurate. Both would work. Both would be accepted. Alright, and then the last one, y over 6 equals 8. Remembering that fraction bar means to
Division.
To divide, it means division, so we see, good, we see division, we're going to use multiplication.
You multiply 6.
And we're going to multiply, yep,
6
both
times
sides
8.
by 6. So we get that y is equal to 6 times 8, which is 48. Okay, so that's just real quick review with our one-step equations. Think about what operation you're seeing, and then how can you undo that operation? What's the inverse going to be? All right, now we're going to move into some two-step. Now, two-step kind of have two main groups. You might have something that looks like this, or you might have something that looks like the one on the right. So we're going to do two examples of both. So if you have something that's like ax plus b equals c, we're going to add or subtract in order to undo that b, to get rid of the b, eliminate the b value. And then we multiply or divide to eliminate the a value. So if we look at our examples, 1, 2, and 3, what example or examples fit this first model? Josue?
Number 1.
Okay, number 1 definitely fits that model, right? Does number 2 fit that model?
No.
No. Does number 3?
No. Well, yeah.
Yes, it's just flipped, right? So 1 and 3, and I'm going to put that here, examples 1 and 3 are going to be like this first one. So it's going to tell us which steps to do in what order, okay? And then example 2 is going to be like our other option. For the other example, the first thing that we have to do, what do you think we have to do with that to get rid of the b? If you look at this expression, yeah, we have to multiply the b value. Okay. And then with the a, we add or subtract. Okay. And this is like example 2. So we're going to go over these together, but you have your steps written out so we know. Okay. All right, so for number 1, do I want to add or subtract my b value? Right, so it's being subtracted here, right, minus 3. So I'm going to add the 3.
Whatever you do to one side, you do to.
Exactly. I'll add the river for those of you who like that. Now, the 3 gets eliminated on this side, so I'm left with the 4x equals 11. And now am I going to multiply or divide?
Divide.
I'm going to divide. Okay. And I'm left with x is equal to 11 over 4. 11 over 4 does not have any common factors other than 1. So we're going to leave it as 11/4. Okay? Do not write it as a mixed number. In algebra, we leave it an improper fraction unless you are specifically told to write a mixed number. Okay? All right, do we want to do example 3, which is similar, or example 2, which is different? The different one? Okay, we'll just go in order. All right, so with example 2, the first step we do here is we have to multiply. What is our b value? The -2. So we're going to multiply both sides by -2. So then on the left-hand side, okay, I'm left with my numerator, the w minus 6. And that's going to be equal to -10. So I've eliminated my denominator by multiplying. And now am I going to add or subtract?
You add 6 to both sides.
We're going to add 6 to both sides. And we get that w is equal to -4. Awesome. Alright, so it's still just 2 steps. It looks different, it looks more complicated, but it's still just following those 2 different steps. Alright, now for problem number 3, again, the variable is on the right-hand side. That's okay, we're still going to follow all of the same steps as before. So my first step is going to be to do what? We're going to add. Okay, we're going to add this 3 to both sides. Alright. What does 1/4 m? What does that mean?
1/4 is 2.5.
Okay. So what do I need to do to get rid of the 1/4?
Convert it to a decimal.
I could convert it to a decimal, or I could multiply by its 4/1, which is the reciprocal, right? So with a fraction, to get rid of it, we're going to multiply, but we're going to flip whatever's in the top and the bottom. So what I'm going to do is, instead of multiplying by 1/4, whatever's in the bottom is going to go in the top, and what's in the top goes to the bottom. It's called the reciprocal. And the same thing over here. Because now I have 1 times 4, which is 4, and 4 times 1, which is 4. So this is equal to 4/4m. But what's 4/4? It's just 1. So I've eliminated that fraction, which is what I wanted to do. And then 4 times 10 over here is just 40. Now again, if you want to rewrite it so your variable is on the left, you can. So then we just get that m is equal to 40. Yes?
You just turn the 1/4 into 4.
You could just multiply it by 4, but sometimes what if you have like 2/3? So I was just showing the 4/1 just so that if it's a fraction other than the numerator being 1, what we would do. Okay. But yeah, you can just multiply both sides by 4. So it's equivalent. Alright, we've got a few more examples we're going to do on the back. Okay. So this is our level S, right? This is kind of our goal, where we'd like everyone to get. This is when we have multi-step equations, we have rational coefficients, there can be variables on both sides. It gets pretty complex, but we're going to be following basically all of the same steps that we just did. The first thing we want to do is simplify each side of the equation. So if it can be simplified, we want to do that first. Okay? Then we're going to add or subtract to get variables on one side and constants on the other. Okay, so we want the variables all on one side, and we're going to put the constants on the other side. And then our final step will be to isolate the variable. And usually that'll mean multiplying or dividing, like a one-step equation. Okay, so we're going to look at a few examples together for what this looks like and how we can do this quickly. So when we look at the first one, -4 times the quantity x plus 3 is equal to 20 minus 2x. So can I simplify this side? Can I get rid of my parentheses? Yes, and I'm going to get rid of the parentheses by using the distributive property. So I'm going to distribute the -4 to both. So I'll have -4 times x plus -4 times a positive 3. Okay. So -4x plus -12. Okay. Now on the other side I have 20 minus 2x. Can I simplify or change anything on the right-hand side?
You can get...
Not yet, right? I can't do anything initially with it. So I'm just going to leave this as a 20 minus 2x, okay? Now, I can't do anything else on either side, so I've done my first step. Now I need to add or subtract so I can get the variables on one side and the constants on the other side. Alright, so do I want to get rid of this negative 4x or the negative 12? The negative 12?
No.
The negative 4x?
Yeah.
It doesn't matter. To get rid of a negative 4x, what do I need?
Add it.
To add it. So I'm going to add 4x to both sides. Okay. So I'm left on this side with just the negative 12 equals 20. And then I have, think about it like you don't have this part. So negative 2x plus a 4x is what? 2x. A positive 2x. Okay? So I moved the variables one way, so now I need to move the constants the other way. So see how like this side is a little heavier. It's got two things. So I know I need to get rid of the 20.
Which is to subtract.
So because it's a positive 20, I'm going to use subtraction. So then on this side, I'm left with just the 2x. And then I have negative 12 minus 20, which will give me a
Negative 32.
negative 32. Okay, now I have a one-step equation. How do I get rid of that 2? I divide.
Both sides.
And I'm left with x is equal to negative 16. So if you want, again, you can rewrite it as x is equal to negative 16. Okay. So it does get more complicated, but as long as you just kind of do one step, one row at a time, none of the steps themselves are necessarily that complicated. It's just when you add them all together, it's a lot more, okay? All right, let's look at problem number 2. Okay, here I have distributing on both sides, so I can do that at the same time, okay? So I can distribute here, and I can distribute here. So I'll have 2 times 12a plus 2, and this becomes a negative 11. Remember, subtraction becomes a negative. It sticks with the number, the term on its right. And then I have a negative 4 times 1 plus negative 4 times negative 6a. So those are both negative. And I use parentheses to make sure I don't mix up my negatives and my subtraction signs anymore. Okay. Let's see if I can, there. Is that better? Zoomed in a little bit. Then I'm going to simplify. So 2 times 12 gives me 24a plus a negative 22. And then on the right hand side it becomes negative 4 plus, and this ends up becoming a positive 24a. Okay. All right. What do we see? What are we going to do? Josue, what do you think? What should we do?
Well, we could either get rid of the 24a or the negative 22. So we could do plus 22 on the left side and plus 22 on the right side.
Okay, so we can add 22. So then we get 24a is equal to 18 plus 24a. Huh. Can this be true?
No.
No. So what does that mean?
No solution.
No solution. So we write that. This cannot be true. No solution. So your solution is no solution. Your answer, your final answer would be no solution. Okay? All right. All right, we got 2 more hanging in there. And I'll share this with you when we're done. All right, so this next one, I put it back here because it has a fraction, but is it really any different than any other two-step equation? No. So, what's the first thing I want to do? Add the 6. Okay. All right, now how do I get rid of 2/3?
Flip it around. The reciprocal.
Right, multiply by the reciprocal. So instead of 2/3, it's going to be 3 halves. Okay. So on this side, it becomes eliminated, and I'm left with y. How do I do a whole number times a fraction?
Put 1 above.
Okay, I put the whole number over 1, and then I multiply. 24 over 2, or y is equal to nope, divide. 24 divided by 2. 12. Alright, good. Okay, now number 4 is a little bit different because there's a lot of fractions with number 4. But we can do something to eliminate the fractions. A fraction just means division. So we can use multiplication to eliminate the denominators. So here my denominators are 3, 6, and 12. What do they all have in common? They can all divide into what?
3.
No, sorry. They can all multiply into what number? Not 3, the other way, 12. Okay? So if I multiply everything, use the distributive property, okay?
So it'd be 12 over 1 multiplied.
Yeah, 12 over 1. So if you see, I multiplied all 3 terms. Okay, every term got multiplied by the 12. And now I can simplify. So 12 over 1 times 1 over 3 will be 12 over 3z. This becomes 12 over 6. And this is 60 over 12. So what is 12 over 3? What? Just 4, right? So 4z. 12 divided by 6 is 2. And 60 divided by 12 is 5. Now I just have a two-step equation. So even though it looks intimidating when you have all those fractions, it's really not, because we can eliminate them by using multiplication. So now I just solve my two-step equation. So the first thing I do is I subtract. And then I will divide.